Hi, everyone, and welcome to the Scott Equipment and Precise Automation webinar. My name is Ryan Summerfield. I'm an applications engineer from Precise Automation. Today, I'll be acting as moderator for the presentation. So before we get started with the presentation, I just want to go over a few housekeeping items. If you have any questions at any point during the presentation, please feel free to ask it using the panel to the right of your screen. I'll be collecting the questions, and we'll answer as many as we can at the end of the presentation. If we aren't able to get to any of your questions, don't worry. We'll have a list of those questions, as well as the emails associated with your sign up, so we can send you a follow-up email to answer your question. Today's presenters will be Darren Burrell. He's the VP of Sales at Scott Equipment. Darren Jacobs, he's the Regional Sales Manager at Precise Automation. And Dalton Dodge, he's an Applications Engineer for Precise Automation. With that, I'd like to introduce our first presenter, Darren Burrell from Scott Equipment.
Hey, good afternoon, everybody. Appreciate you taking time out of your schedule to join. Most of you are probably familiar with Scott Equipment Company. We're a local distributor here in the Carolinas and Virginia. So we're located just outside of Charlotte, North Carolina, in Huntersville, North Carolina. So we've been in business for about 40 some odd years. So back in 1977, David Scott founded our company, bringing the principle that he founded it around bringing fluid and power and electrical components together under one technical distributor. So as you'll see, we do parts and pieces, but some of our main business is doing assemblies or kits or solving problems, right? So one of the main things we pride ourselves on is trying to make automation simple. Okay? So we have the local support, both outside sales, customer service, and program manager, located across North, South Carolina, and Virginia. So we should have somebody there pretty close to your facility to be able to help support you. The 3 S's that I always talk about when we're talking to customers are, the support, the stock, and the service. So having that local person that can come out, second set of eyes, we try to pride ourselves on. We are very generous on our stock. So we have over $2 million worth of inventory here locally, 6,000 items from fluid power to electrical controls to, accessories for robots. And then with that service, we have an extensive staff of engineers and experience that we have on board, not only with our outside sales, but our program manager and customer service. So in the next slide, we'll talk about is some of the value-added services. And I feel like value-added services is thrown out there pretty big. So we're here to complement our integrator partners, which are customers. So we're not doing the complete turnkey package to be able to offer customers that complete solution to do a conveyor system. We sell conveyors, we sell robots, we do end effectors, but we try to do a lot of different sub-assemblies, kits, specials. So we really try to provide ourselves in the we build it, you install it. So if we can put it all on a pallet, ship it to your location, we can also come out and give you some guidance on programming. We do some classes for robot programming, whether it's at your facility or right now virtually. We can actually put together a complete package for a robot solution that would include end effectors, a base, some guarding if you want it, even though you don't need it with these collaboratives, safety sensors, laser safety scanners for the laser markers. But you let us know. As you can see on the screen right there, the van, we can come to you. So in our van, we have the Precise robot that we're able to showcase. So at the end, we can talk a little bit more, but at this point, that's all I have about Scott Equipment Company. Appreciate Precise doing this. Stay tuned, and here they come. The next presenter would be, I believe, Darren Jacobs. You're going to kick us off?
Yes, I will. Thanks very much, Darren. As mentioned, I'm a regional sales manager for Precise, and I just happen to also be located in sunny Huntersville, North Carolina also. and I'm in a different time zone, so I handle most of the US distribution for Precise. Now I want to take the time to start out with the kind of the story of Precise's founding. It's a very interesting story, I find. If you look at this picture here, this picture is in the Smithsonian Institute. You can see a Puma robot located there. And the two gentlemen in the middle, the second from the left is Brian Carlisle, and then to his left is Bruce Shimano. Now, Brian Carlisle handled all of the, they were out of Stanford University, and he handled all of the electrical mechanical design, and then Bruce Shimano handled the software development for the Puma robot. And that was a significant innovation. It was actually the very first electric robot introduced to manufacturing, and it started pretty much manufacturing utilizing electrical robots in both Europe and the United States. After selling that to a company called Unimation, the gentlemen obviously like working together, so they started a second company, and that company is called Adept Technology. Adept Technology was really the benchmark of excellence in SCARA design, high-speed industrial SCARA robots that were used primarily in assembly type applications. So well without all different industries, especially the automotive. In 1983, they sold Adept to a company called Omron, I'm sure you're familiar with, and then they formed what is now today Precise Automation. Now, Precise Automation headquarters is in Fremont, California. That's right down the street from Tesla. It was formed in 2004. It's a very lean company. They utilize a lot of different types of methodologies. One of them is called contract manufacturing. Defense contractor down in Southern California, actually in Tustin. We just basically rent time on machine and floor space and build to order. You know, we build on a quarterly basis. We get a high amount of orders, and we can adjust our production based on that. So we're one of the few companies that actually manufacture robots in the USA. Now, what do we do? Well, basically, they started the company built around their microcontroller technology. This microcontroller technology was utilized in automating precision machinery and then and robots. You can base a robot around it. So that's exactly what they did. They had the software and the controller. They went ahead and said, hey, let's make some unique robots in the industry. And since they worked in industrial prior to this, Cobots were just coming about, and they just said, hey, why don't we focus our energies on this whole new innovative market of collaborative robots. So this is the first Precise Place 100 series robot. Comes in both an XZ configuration and an XYZ configuration. I might add that it's the only collaborative Cartesian type robot that's in the marketplace today. After having built that, they came out with another innovation in robotics. This is a SCARA design robot. It's the PF400 and 3400 series Cobots, and they can both be put on linear rails that are also collaborative. And I might add that we're the only ones that offer a collaborative linear rail. The linear rail comes in 1 meter, 1.5 meter, and 2 meter lengths. And the SCARA designs are in 400 millimeter Z-stroke, 750, and 1160 Z-stroke. Now, a significant difference in this technology versus traditional industrial SCARAs is that the Z-stroke is at the back of the system. It's not out in the front. In other SCARA designs that are still available in the marketplace, industrial in nature, the stroke is only 200 to about 220 millimeters in length. So this gives us a significant advantage over the competition, even if we were to compete against industrial designs, in that we have a cylindrical envelope that's created with the Z at the back, and add the track to it too. It even adds for a bigger work area, but Dalton will be going over that when he goes over the technical aspects. Now, moving right along to our new innovations, we actually have a new design coming out at the end of the year. This design is called the Precise Flex Direct Drive Series Cobot. And it's going to come in both a 4-axis and a 6-axis configuration. This was earlier this year. You could see this is the 4-axis version with a 5th-axis gripper on the end there. It's a significantly different design than anything out in the marketplace today. It's got a direct drive base motor, our design, and also out on the elbow is another direct drive motor. Now, versus harmonic drive construction, these direct drives will have 0 reflected inertia, so it basically will stop on a dime. And its configuration here allows it to have a pretty decent envelope, can go 360, a great robot for loading and unloading inside a machine. If you had the articulation of the additional 2-axis we can put on here, and also palletizing or in-feed, out-feed of conveyor systems. So we're very excited about this robot that's coming out at the end of the year. It's already been through beta testing. We really are going to see a huge demand in this cobot. Now, one of the questions I receive quite frequently is really, what is the difference between collaborative, our collaborative, and everybody else's collaborative? Well, if you look at this first video here, this is an industrial robot. So back around 2012, 2013, they started to put in area floor scanners and call this collaborative, basically. The robot would slow down, come to a stop, operator comes into the zone, he does what he has to do, checks the parts out, checks the robot, and then he says, oh, I'm gonna get out of here now. So as he moves further away out of the zone of the robot, you can see the robot comes back to work. So this is basically, in my opinion, what I would call semi-collaborative. It's not fully collaborative because both guys are not working at the same time here, robot or the operator. Now, if you look up in the upper right-hand corner, this is what we call collaborative, being able to work side by side. We only exert forces that are safe. You cannot make this robot go faster to where it would be unsafe and violate any of the ISO specifications for collaborative safety. So Dalton's going to be up next here. Dalton Dodge, he's one of our application engineers. He's going to go through how easy it is to program one of these cobots. So with that, Dalton, please take it away.
Thanks, Darren. You're going to see 3 videos coming up here that are just going to highlight some unique features we think separate us from the rest of what's out there. The first of which is basically being able to manually teach these things by hand and how easy it is. So unlike other robots and other cobots you see on the market, we actually don't use the same type of mechanic selection you would normally see, which is, high friction gearboxes, harmonic drives, and that such. As a matter of fact, we use incredibly low gear ratios by belt systems in our mechanics, and it serves a few purposes for us. It allows us to have a very small forward reflected inertia, which in turn makes our cobots much more sensitive to collisions with our current sensing technology. We actually don't use torque transducers in our links. It also allows us to move at the fastest collaborative speeds at 1.5 meters a second. And what you're seeing here is myself using guidance motion, our graphical programming interface, just one way we can program our cobots. And I simply free the axes with the press of a button. I position the gripper to my desired point, put the fingers around the part, press record, and then within a few simple steps, I have a basic pick and place application or something more complex executed with minimal effort. One final note I'll say is we consider our robots extremely green. On average, power consumption with these is less than 200 watts normally. So it's pretty impressive, I feel. Another unique feature we like to demonstrate is the power of our error and exception handling and the low collision forces of our cobots. So we always opt to show this pinch point collision, as you saw earlier. And with many other systems, you're going to, of course, have alarms raised on the factory floor. You're going to have downtime in work cells. And most importantly, you're going to have an injured operator. With our error recovery, we allow for obstacle avoidance, jammed parts, as well as missing parts. I will note that collision testing has been performed and certified by TUV, and a table of all of our collision speeds and forces are provided in our manuals for reference, end user's reference. So collisions in the work cell are another type of error and we can handle, and as seen here, I'm just making a few checks with the guidance motion. And given a few seconds here, the robot's gonna make a few system checks and then get back to work. Coming up, you're gonna see if inconsistent part presentation is an issue, you can simply add that feature into an already existing recovery routine or motion routine, and the robot will continually try to check for a part. And this is, of course, completely modular, so you can design it to your application needs. And lastly here, you're going to, as an example, showing an operator in the work cell with the Cobot. So if a collision happens and the operator says, needs some time to adjust the Cobot after a collision, you can add exactly that, maybe move it around some more expensive hardware in the work cell, and robot will get back to work. And last thing I'm going to talk about is kind of our unique kinematic design and linear axis advantage. So our cylindrical working envelope is another feature that differentiates by our unique kinematic geometry as seen here. So you have your typical 6-axis spherical work envelope, and you have our unique cylindrical envelope. But we'll take it a step further, and how do we expand that and make it more effective? So we offer a collaborative linear rail, and you're seeing me to simply plug and play. So mount it onto the rail, plug in a few cables, and voila, that linear rail shows up as a new 6-axis or 5th axis for this robot. Very, very effective for your storage and retrieval systems, inventorying systems. We do implement a master-slave architecture between our controllers, which is what makes it so easy to say, swap our gripper onto a robot or the rail onto the robot. And what you're going to see here is just a few snippets and a few blurbs about the comparisons between a traditional 6-axis work cell and our compact space-saving precise flex work cell. With the traditional spherical envelope, you can access, let's say, a wide area, but maybe not the entire volume efficiently. You really have to plan to reach that upper height and the lower height for your 6-axis. With our work envelope and our rail, end users and integrators can save factory or lab space by effectively using the entire working volume by accessing all heights at all times. And with that being said, I'll pass it back to Darren. He's going to go over a few application videos and some notes.
Hey, thanks very much, Dalton. Yeah, the next montage of videos here, the first one out of the gate does show the linear axis here, and it's actually utilized in, let's see if I can get the thing going here. Okay. Whoops. Had a restart on the video. Apologize for that. Okay, there we go. So you can see the linear rail, and this is tending 3 3D printers, a dunk tank, and a dryer. A very optimum way of, lights out and handling those machines. Here's a dental milling application that's actually machine tending that process. So that's another nice use of it. This is kind of exotic. This is a tomato picking application using some advanced vision systems and temperature sensing. And it's on a mobile platform with a custom gripper there. This company really has something different for the marketplace based around our system. This is more of our traditional space that we've occupied, life sciences. We're very big into that area, and mainly because of the unique design of our Cobots. As you can see here, a 6-axis would have trouble working at all these different levels and handling these small micro titer plates in these tight spaced areas. In the next picture here, you can see how easy it is to have some very small manufacturing floor plans and monitor and handle all of it. Here's a general industry custom gripper doing different types of applications, using a flexible feeder for small parts, dunking them, inspecting them. But you notice that there's not a lot of safety fences around here. There aren't any at all, actually. This is an automotive application where they are placing a magnet, and it's on the transmission filter. That's a repetitive task. And so as this company is trying to learn and adapt the technology to collaborative technology to manufacturing, that was one of the tasks that they were trying to get rid of, actually, a person handling parts doing repetitive work. So that's they're just going to build on that, basically look at workflows and see if they can offload any simple pick and place operations to the robot, and that's what it's all about. We're not trying to replace industrial robots here. It's a totally different animal. So we're trying to look at a manual operation in a plant and see how we can offload the repetitiveness of the tasks. We're looking for small areas where our unique geometry would be best served. So like I mentioned before, a lot of the robots out in the industry right now in the collaborative space, they're all pretty much 6-axis cobot design. So this gives us a competitive advantage when we start looking at these different applications where we might just have that better cobot for the job. We're looking for payloads under 7 kilograms. We feel that if you go beyond that, you start to get on that ragged edge of where your payload is actually not very collaborative. And it really then, in a risk assessment, you would have to make sure that your gripper complies and everything else for the higher payloads, and you don't run into any difficulties. As mentioned, we're looking for longer than 3-second cycle times. We're not trying to do a part a minute here because it's just not a high-speed device. As you go faster with mass, it's then going to exert more forces, and when those forces exert the ISO standards for safety, well, then it's out. It's not collaborative anymore. So we don't want to do any of that. Another great application for our cobots is in the mobile platform applications. In this lab partner scenario here, you can see it's a very clean installation of our cobot on a mobile platform. We have embedded controllers into the cobot, so there's not a big tower-sized controller or anything like that hanging off the edge. You just have two cables of power and an Ethernet going down in the base. This one also has a camera implemented that's taking a look and understands which plate it has here. In addition to that, we're looking for, I mentioned before, applications to replace an operator, not an existing industrial robot application. A lot of the past applications, especially in automotive, everything was about cycle time. If they couldn't meet that cycle time for manufacturing, they would just keep throwing more robots at it until they could get a cycle time that they wanted. Where our cobots fit into play in automotive or manufacturing is more in the what happens to that big multi-million-dollar production line in automotive when they find out that, hey, it's not very flexible, we need to add more robots, we need to change for a different model, things like that. What cobots allow automotive customers to do is actually working off to the side on new product development, prototyping, right-sizing processes and lines. They can do all of that and deploy and redeploy these very easily. So that's a big advantage to us, is to be able to do that. They can figure out the workflow and the process, and then they can turn around and say, hey, we've got this all figured out. How do we increase its speed? We'll probably have to throw some industrial grade robots and then have the safety fencing come back into play. So that's the big key difference between collaborative and industrial. In closing summary, I want to just tell you what we talked about. Basically, precise automations, one of our key advantages is our embedded controls, like the microcontrollers that are inside the robots. As you saw on the mobile platform, it made it a very clean and easy to apply application. Unique geometry that Dalton discussed, the picture down there is the cylindrical work envelope versus the spherical work envelope of all the other 6-axis robots in the industry. So we feel we can cover more ground and be more efficient at multiple levels of reach. And that's going to be a key advantage when you're trying to pick a cobot for your application. We do have the only collaborative Cartesian cobot and collaborative linear rail. We have the fastest speeds in the industry. Dalton mentioned 1.5 meters a second. A lot of our competitors can only go and remain safe half that speed. The low incremental cost. It's when you compare this to, like I said, the multi-million-dollar lines or all the safety fencing and scanners and safety, everything like that goes into the cost of those very large lines. These are deployable, redeployable, reconfigurable, simple cobots that you could have sitting on the shelf and go out and actually adapt very quickly to some pick and place routines and start to develop your process flow. Flexible automation, that kind of is hand in hand with that. We basically are very flexible when compared to inflexible hard automation that's guarded in industry. Easy to teach by hand, as demonstrated by Dalton. Very easy to use user interface called Guidance Motion. We'd be happy to do more demonstrations of that. You just have to call up your folks at Scott Equipment. And then it's a low power green robot working off of 48 volts. It only utilizes up to 200 watts. So that's, you know, better on the pocketbook too when you compare it to other things that are out there. And with that now, we're going to go into, I'm going to reintroduce Ryan Summerfield, and he's going to talk about all the folks that had questions online and throw them at the panel here.
Yeah, so I just have a few questions that I've collected. So I'm going to start off. Start off with a question to Dalton. So the question is the linear rail collaborative too, or is just the robotic arm?
Yeah, as I previously mentioned, because of the way we have designed our controller topology, essentially, everything is kind of considered master slave. So when you mount that robot onto the rail and get it talking with the host main controller that's nested in the arm, that rail becomes fully collaborative by nature of communicating with our main controller. So it's collaborative, fully collaborative.
Awesome. I'm going to kind of transition a little bit into a topic that I think is probably on a lot of people's minds, and especially important for the business aspects of these companies. We'll go first to Darren Gurel and then to Darren Jacobs. So how has COVID-19 affected your operations, and what changes have you made to account for COVID-19? Darren Gurel.
Sure. So as most, it's affected everybody in some form or fashion. We've continued to support customers as they see fit in a safe manner. So if you're needing to see an outside salesperson to help you with an application, we're able to do so. We're trying to do a lot of the qualification prior via go-to meeting or team meetings or some virtual aspect in that neighbor. But as it stated right now, we are shipping product every single day and continue to support our customers as they see fit and as they see they are comfortable with. So
awesome. And Darren Jacobs, you want to talk on behalf of Precise Automation?
Yeah, absolutely. Well, as we're out in California, you know, and that's area has been very hard with a lot of the restrictions, and we manufacture out there. So we've done our best we've increased manpower, actually hired folks during this tough time to try to manufacture the Cobots. We did get an increase in demand because we're primarily in the life sciences, and a lot of our Cobots are used today in laboratories for, guess what, vaccine testing. So everybody put in large orders as soon as COVID hit. Then we just basically had to solve our problems with ramping up production and trying to manufacture more for the higher demand. Now, at the same time, we were hit with the restrictions. So therefore, the increased guys had to be, the workforce had to be distanced apart. So it was multiple issues to try to hire the right people, but then you lose it because you can't have them working next to each other. So that's one aspect. We have been attempting to, we don't go on a lot of sales calls anymore because traveling all over the US right now, a lot of the companies that we normally would go in have the restrictions, so they can't have visitors. So that's kind of put us down in that respect, but yet we've been proactive in trying to do these webinars, and hopefully at least our opinions of our customers so far has been that there is some value from these, and we're going to do more and have additional types of topics covered. So that's about it, Ryan.
Awesome. Okay, I've got another question for Dalton. Is there any type of restrictions for end of arm tooling for the robots? What type of end of arm tooling can you guys can these robots support?
Sure. So we work with, I guess, all the up and coming big names. So On Robot, our partners. We work a lot with Shunk, Schmalz, kind of all those new collaborative grippers. But as far as restrictions go, 48 watts or like 24 volts at 2 amps for power. So for electrical grippers. Nothing larger than about 3 kilograms. So that's not including the obvious the part payload itself. So yeah, about 3 kilogram payload for these robots, 48 watts for electrical grippers. Pneumatic grippers are also very compatible with the 3400. And that's really about it I can think of. Yeah.
So I guess if I can interject, this is Darren Burrell on the end effector side.
Sure.
So a pretty nice feature in the Precise Automation robot is they actually have internal, both electrical and pneumatic functionality to get to the very end effector. Okay, so on the very end of that robot, you can get both air and electric, as they said. So if you have a need for a custom gripper, that's something that Scott Equipment, we can help put together that package, or also work with a couple of the 2 engineers you're hearing on the phone right now to come up with a custom gripper if your application needs to. So pretty much most all of the end effector products, whether it's pneumatic or electric, will work with the Precise. It's just a matter of getting the right adapter to be able to do so. So I'd encourage you to talk to your local account manager. Contact information will come up at the end here on the slide, but end effectors are pretty easily done with this one.
Yeah, thanks for that.
Yeah, awesome. Thanks for answering that question, guys. So so we talked a lot about different end of arm tooling, and so just kind of a little aside, along tangentially, I saw vision integration in some of the videos. Is it easy to integrate vision into these robots as well? Does it come standard?
To that note, I wouldn't necessarily say it's standard, and then the ease of a vision application or integration, I guess, always, of course, calls for the level of your application needs. But we've had numerous successes with people integrating like 2D barcode scanners out onto the actual grippers themselves. So as Darren just previously mentioned, not only do we bring out electrical like I/O signals and pneumatic lines to the end of arm tooling, we also bring out serial lines, and then the new robot will bring out Ethernet lines. So you'll be able to interface with all the kind of new IoT style barcode scanners and stuff out on the gripper. And then setting up a fixed mount camera, say on like upstream on a conveyor system, it has been done in the past with our system, so it is definitely doable. And we've had numerous success stories with vision integration with these robots.
Awesome. And then I guess just final question to wrap up, and I'll pass it over to Darren Burrell. How can I get access to one of the robots or a proof of concept for my application?
So if you can go to the next slide, I might be able to answer that. So that's kind of where I was hoping to end. Kind of leads into, thanks for taking time out of your day to join us. But if you've heard something here, you want to find out more, you can see the van right there. That van is equipped to be able to come to you in a safe manner. If you go to our YouTube page, you can see some videos about what we carry in the van. But the Precise robot is in that van. It can be operational in your parking lot. So we're not having to log it into the building or anything else. We can be outside. We do have all the CDC guidelines covered, face masks, sanitizer, social distancing will be covered during a live demo. That can be interactive. So we can also do some proof of concept videos for you. So if we can go show you the robot, talk about your parts, we have robotics engineers on staff that can kind of do a proof of concept video for you to show the feasibility of having it done. All right. So if you can write down that web address, robots@scotteq.com, send us an email. we'd be happy to schedule a live demo or come to you and talk about your proof of concept or an application that you feel would fit best. So, or that's our 1-800 number. You can call that in and one of our customer service staffs will answer the phone, be happy to take down your information and get it to our account managers and get the van out to you and get a demo out to you to be able to help do that. So, but it all starts with you guys. Just send us an email at robots@scotteq.com. Other than that, I just wanted to say thanks for joining everybody. On behalf of Scott Equipment and Precise Automation, stay safe and we'll get this through together. So let us know how we can help. Mr. Jacobs, is there anything you'd like to add?
No, I appreciate sharing this event and look forward to communications with the customer base here. So thanks again for your time and everybody stay safe. Thank you.